Okay, so we covered a few things today in class. I talked about, but didn't show you, adding or making the destructors in both the card and deck class virtual. So here in my card.cpp file, I've added a virtual destructor, and in the card.h file, and it's reflected again. Because previous to this, I had just I let the compiler synthesize a destructor, and because I'm calling it out and saying it's virtual, now I have to add the implementation, have it specified in the implementation file, or declare it inline in the .h. Anyways, there it is, virtual. And same with deck, I've added a virtual destructor to deck. Now the homework that we went over today was our new CardButon class. Very simple class. We just added a member called index along with the getter that returns a size type. Returning that index, I have a constructor that takes an index now and also takes a QWidget pointer. Depending on how you created the class initially, Qt might have put a QObject pointer in there, but it needs to be changed to a QWidget pointer if that's the case. And if I look at my CPP file, here I have my constructor, and in the constructor, this initialization list. So the first thing I do is I construct the base object, passing it the parent pointer. So I have to do that because the base object needs to be constructed with a parent pointer if we want it to behave, be part of that graph of pointer inheritance. And then I just set the index to the thing that's passed in, and I'm typing that as size_t again, as we discussed in class. Then we made some changes in our main control loop. One of the things we did is we got rid of the deck. We no longer have a deck member. We still use a deck, but we just use it temporarily. So if we look in the CPP at the start, whereas before we had a game object that we created and was stored in the member, we really only use the deck just to deal the cards for the game. So we construct it. Now we still put it in a unique pointer so that the memory management is done for us. If we didn't do that, we would have to do a delete. We'd do a new playing card deck. Remember, new creates that object, that playing card deck object on the heap. So if we do a new, then it's up to us to do a delete at some point, or we have a memory leak. And by putting it in a smart pointer, whether it's a unique pointer or a shared pointer, we're passing on that smart pointer is taking the job of managing that memory. So when that pointer goes out of scope, it will delete that playing card deck, which is fine. We only need that playing card deck long enough to pass it to this new for the card matching game. So we are going to create a card matching game on the heap. It's going to use count cards that is set as a constant at the top of this file, and we pass it a pointer to that playing card deck that we just created, and it deals the cards from that deck. Once that's done, we forget about the deck. At some point you're going to add a new game button, which is going to reshuffle. You're going to just construct a new deck and create a new game using a new deck. The game is a member that we're going to keep. It's our it's our model, so it represents the state of the game at any time, and we store that in a member variable, the unique pointer to that game. And again, it's a unique pointer. We always use smart pointers. Okay, and then this is the same exact same button creating stuff as we did before. The only difference being I have changed everywhere where it was Q push button before, it's now a card button. And in my card, I also, this for loop was the loop variable was I before, and I changed the name to index because I thought it was more descriptive. And you can see why right here. When we create the card button, the constructor takes an index as well as a parent widget. Now, because these buttons are being put into grid controller right away, I don't think you actually need to specify the widget. If that's the case, there's a default value for that of 0, and it will be constructed without a parent widget, but I think it's better to specify it. Okay, so I instantiate a new card button, and these are not in smart pointers, they're bare. But because they are QPushButton objects, and because I'm specifying a parent pointer, Qt is taking care of memory management for me. So the parent widget will manage that memory, and when the parent widget exits, that memory will be cleaned up. Again, this is all from before we set the size, push the button onto the card buttons vector, and place the button in the grid. So all of that's the same. I have this qdebug statement just to verify. Remember, I put that in at the end of last class to verify the size. So those are the changes related to the card button. And then we created this draw method, which we're going to use because now we're moving all of the game logic out of the controller. Before, what we used to do is keep state in the controller. The controller remembered if the card was face up or face down, and when you clicked on that card, it switched it from one to the other. Now what we're doing, especially because other cards may change now, so we're moving all of the game logic into the game, and in our on card button clicked, all we're going to do is we're going to tell the game which card was selected by the user, and then we're going to let the game change its state. And once the game state is changed, we have to redraw the UI, so we're going to redraw it. This is the whole reason why we changed to a card button, so it would be easy to get the index. Now, this is something I did, we didn't do in class. I created a little utility function. It's not even a member function, it's just a utility function in this CPP file called Getsetter Index. I did a forward declaration of it up here so that it can be used anywhere in the file. But because it is just declared in this implementation file, its scope is just this implementation file. And all it does is it receives a pointer to a QObject, it casts that pointer as a card button, and then asks the card button, what's your index, and returns that. Okay, so because of switching from push buttons to our card buttons that know their index and have a get index function, I'm able to create this little utility function that just takes the pointer to the sender object and returns the index. And I just use that utility function right here. So my handler for that, for clicking on any card, is just 2 lines of code. I tell the game which card the user selected, and then I redraw the interface. And we did this draw together in class. So I'll just leave it here for you to look at. But essentially what we do is just we iterate through all of the buttons. So index goes from 0 to the number of buttons or cards in the game, which is the number of buttons in the screen. And we iterate through each button. And this time, instead of grabbing a new card from the deck and showing a new random card, we ask the game for what's the state of the button at that index. So the first thing I do in this loop is I go to the game and I get the card at that index. And actually all of these things, I'm just declaring a bunch of strings here, I can even move them outside of the loop just to make it even clearer. They don't need to be outside of the loop. Generally, it's best practice to make declarations as close as you can to their actual use. But I think this makes, they were sort of just getting in the way of understanding what this loop does here. The loop looks more compact now. So I iterate through all of the cards in the game. Each time I'm getting the next card, the card at the next index, and then I ask the card, are you chosen? If you're chosen, that means I am showing the face of that card. In class I used an if then else, but here I'm using the ternary operator. I'm asking that card if it's matched. If it's matched, I'm going to show the gray card front image, and if it's not been matched, I'm going to show the white card front image. I set the card text to the text I get from the card. I do get contents, and I set the suit color. Again, I ask the card get color. Otherwise, if it's not chosen, I'm showing the card back, so I set the image name to card back, and I set the card text to null. Then I call this style, well, I create my style sheet string. It's a Q string, and I use the .arg twice to fill in the name of the card image and the color of the suit. I then set the style sheet for that button. So CardButon at index gets the style sheet I just built, and it gets the text I just built. Okay, so I just iterate through and set up all my buttons that way. And now this is really what a game should look like. The user makes a selection, I tell the game object the user chose that card, and then I redraw. So we did do a little bit of work in card matching game, and you had some homework in card matching game. So we have this card matched at index, and I've changed this a little bit from what we had in class. In class we said if the card is matched we return right away, and I just changed it around a little bit, and all I do is I have an if statement. So all of this stuff I only do if the card's not matched. It's functionally the same. I just like the looks of this better. Okay, so the user has chosen a card, and that's when I call this. The UI is telling me, the controller is telling me the user chose the card at this index. So the first thing I do is check. Well, I get the card that's at that index. Remember, this card pointer is a shared pointer, a smart pointer to that card. If the card's already matched, I'm not going to do anything. But if the card's not matched, if it's chosen, I'm going to unchoose it. And if it was not chosen, pardon me, if it was chosen, I unchoose it. That means it's already face up, it's chosen, but it's not been matched. I'm turning it back over. Otherwise, I've chosen a card that was not already chosen. And this is where your homework came in, and I did show a little bit more than I had planned on the screen, but this was your homework to do, and that was first in this section, you have to decide, well, what do you do if it's chosen? If I'm turning up a second card, then I have to look and see if there's any other cards that I'm going to match to, and I call the matching routine on the playing card, and I return points depending on how many points it's worth. So there's some code that goes in the playing card. We've got playing card match. Oh, I haven't even implemented it here. In yours, it is implemented. Okay, so I added in the stuff that we did in class. So this is in the card matching game, choose card at index. So this is what happens when the user chooses a card. So the first thing we do is we get the card at that index. We check if it's already matched. If it is, we do nothing. If it's already chosen, then we just set chosen to false. That just means it was face up. Now it's face down. Now, I've done something a little different. In class, I just had you guys find an other card. For your assignment, you're going to be matching, you're going to be playing a 3-card game, so you're going to have to be passing a collection of 2 cards. And so I'm giving you an idea here on how to do that. So I've declared a vector of other cards. Now, for right now, that's only going to ever have 1 card in it. But when you want to change to implement a 3-card match game, or maybe a 4-card match game if you're that ambitious, then you have to start passing a collection of cards, not just one. So this shows you an outline of how to do it. All right, so I have this other cards vector, and then I'm going to say for all of the cards in the hand, I'm going to check every other card, and if it's chosen and it's not matched, then I'm going to add it to my vector. So other cards dot push back. And actually, I should be doing this match afterwards, so that's a little awkward. But for right now, I know it's only ever going to be 1, and that's why this break works. So it's just, I'm just showing you how to put this thing in a vector and pass it. So I push it back. Now normally I wouldn't do a match until I have all of the other cards in the vector. So you're going to have to work that part out. But I set match score. I call match with in class. I think I just called it match, but I'm calling it match with other cards. If there's any score, I increment the score. I set the card, both cards, the one that the other card and the current card matched equal to true because they're now matched. Otherwise, if there's no score, I set the other card set chosen to false because I want to turn it down. All right, and implementing this card match with other cards function was your homework. And just to show you that this works, I don't have my gray back of card inserted yet, but you can see when they're matched, they remain matched. And when I click on them, nothing happens. Okay, so that's what we did today and your homework for tonight.